So on page 6 in your notes, we did numbers 1 and 2. We were ready for problem number 3 down at the bottom of the page. So let's look at what we have here. We are supposed to find these angles listed over here. Remember, the middle letter, when we've been given a 3-letter name, is where the angle makes its turn at. So if I want to go find angle BCD, here's B, follow that down to C, and then over to D. This angle right here is the one that we're looking for. There's angle BCD. Do we have enough information to be able to figure out the size of angle BCD? No. What kind of triangle is the right-hand side over here? What kind of triangle is that? What kind of triangle is that I just highlighted? What type of triangle are we looking at?
Like it's an acute.
It looks like it could be acute. I don't know how big the angles are, though, so I can't say that definitively yet. But there is enough information up there that there is one of the classifications that I could definitively give. Isosceles. What did you see there that told you that this was an isosceles triangle? These double congruence marks on these two sides right here. That tells me that this is an isosceles triangle. Because we have a pair of congruent sides. So we have an isosceles triangle. And if you look at what we wrote down up at the top of this page, we have an isosceles triangle theorem. Because when I have two sides that are congruent, what does that mean about my angles? The opposite, not the opposite sides, because I have sides. Opposite angles are congruent, yes. So when I have an isosceles triangle with two congruent sides, the angles that are opposite those sides are also congruent. So opposite this top side up here, that would be this angle right down here. So this angle is congruent to, then I go from my other congruent side, the one on the bottom, I go to the opposite corner, this angle right here.
How do I say this? You're pretty much saying that with the sides I have here, congruent sides, they're congruent with the opposite sides?
They're not congruent to the opposite sides. No, the angles that are opposite the two congruent sides are congruent to each other. Sides and angles can't be congruent to each other because a side has a measurement and an angle has degrees. They're not measured in the same units. But when you're looking at a triangle, say like this, and I have two congruent sides like this, the angles that are across from, opposite those sides, so this angle right here and this angle right here, these two angles are congruent to each other. So if this angle is 30 degrees, then this angle would also have to be 30 degrees. But this side is not 30 degrees because sides aren't measured in degrees. This side could be something like 5 centimeters. And then this side over here would be 5 centimeters. So the angles across from the two sides that are congruent to each other are the same size. Does that make a little bit more sense? All right. So I know that this angle up here, 54 degrees, is congruent to this angle down here. So how big is this angle down here by D? 54 degrees, yes. All right, so let's go ahead and add that to the picture. Oops. This is 54 degrees. All of the angles over here have been given a 3-letter name What is one possible name for this angle right here? CDB. C over to D and up to B. It makes its turn right at D. Here's angle CDB. So that would be 54 degrees. That's what we just found by saying that it is one of the base angles. It is across from one of the two congruent sides. Now do I have enough information to find angle BCD? Yes. Because the three angles in a triangle add up to 180 degrees. So the measurement of angle BCD plus 54 degrees plus the other angle that's 54 degrees is equal to 180 degrees. Let's combine our like terms together. What do I get when I combine 54 and 54? 108. So the measurement of angle BCD plus 108 degrees equals 180 degrees. And then I'm going to subtract 108 degrees from both sides. What is 180 minus 108? 72. So the measurement of angle BCD is 72 degrees.
Back to the 54-degree angle. So if I'm not wrong, both of the 54-degree angles are congruent with one another.
The 54-degree angles are congruent to each other, yes. And they are congruent to each other because the sides that they are across from are congruent to each other. Yes. All right. Let's look at the next angle that we are supposed to find. It says find angle ADB. So it's going to make its turn at D. Here's A over to D and then up to B. So this angle right here is what we're looking for now. Do I have enough information to find that angle?
No.
Look carefully. Yes, I do.
Because
what do we call this angle pair right here?
linear.
A linear pair. And linear pair angles always add up to how much? 180. So I can do 180 degrees minus the 54-degree angle that it's right next to. And we get what? 126 degrees. So this is 126 degrees. All right, we have two more angles left to find. We need this angle here, and we need this angle up here. What do we know about those two angles? This one and this one. You could go with remote interior angles. You could call this angle right here the 54-degree angle. It is exterior to my other triangle that I could highlight in yellow. That 54-degree angle is outside of the yellow triangle. So this is exterior to the yellow triangle. And in that case, these two angles would have to sum up to 126 degrees. But I can think of lots of things that'll add up to 126 degrees, like 126 would add to 126. 64 and 64 would add up to 126. Sorry, 54 is what my outside angle is, not 126. I could add 50 and 4. That would add up to 54. I could add 27 and 27. That would also add up to 54. I could do 20 and 34. So I need a little bit more information about these two angles. What else do you notice in that picture? Yes, sir.
That not A. B is next to the 54-degree angle.
It's next to a 54-degree angle, but together they don't make a straight line. So I can't minus it from 180. We've got some lines that are congruent. What are some segments that are congruent that touch my yellow triangle? Which one? BD. This line right here is congruent to what? AD. This line right here. We have these congruence marks on them. So that yellow triangle is what type of triangle? This is an isosceles triangle. Mm-hmm. Just like the first one, because we have two congruent sides. And if I have two congruent sides, what does that mean about the angles? They're equal. They are congruent also. I have two congruent angles. This angle down here, angle A, because that is opposite side BD. And this angle up here, angle ABD, because it is opposite side angle or side AD. So those two angles are congruent. Since I don't know how big they are, I'm going to call them both x. So I would have x degrees plus x degrees equals 54 degrees. These two angles here are the congruent remote interior angles. We know they're congruent because they're part of an isosceles triangle. And this 54-degree angle is exterior to the yellow triangle. So I would have 2x equals 54. And then I divide both sides by 2. What is 54 divided by 2? 27. So x degrees equals 27 degrees.
And where did you get the x's from?
I made up the x's. I knew the angles were the same size, but I don't know how big they are, so I have to have a variable to represent that. You can use x, you can use y, you could use q, but we don't know how big it is, so we had to pick a representative for that.
So are you talking about the congruent angles on triangles?
I'm talking about the yellow triangle here.
All right.
Yep. The two congruent angles would each be 27 degrees. So you could do it like that, or if you don't like the remote exterior angles theorem, you could do x plus 126 degrees equals 180 degrees. That would give me 2x plus 126 equals 180. But notice what happens when we subtract 126 from both sides. What is 180 minus 126? 180 minus 126. 54. That's exactly what we had over here. That is the size of that exterior angle. So you get the same answer whether you do triangle sum theorem or exterior angle theorem. You get that x is 27 degrees. So those two angles are each 27 degrees. All right. Let's go ahead and flip over to page 7 and look at some of the problems there. There are 4 problems on that page. Oh, sorry, I did not mean to go past that problem. Okay, so on number 4, We need to find the measures of angles B and C. So we're looking for this angle here and this angle over here. Do I know how big any of the angles in that triangle are?
Yeah.
We know how big angle A is. Angle A is up at the top. It is 70 degrees. Do I know that angles B and C are the same size?
No.
No. Well, if I knew what kind of triangle I was working with, it might help me determine whether or not those angles are congruent, because if it's equilateral or isosceles, I would have some congruent angles inside this triangle. How big is side CB?
8 boxes?
8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. So we have something that is 8 units long. We can just count the boxes because it's going horizontally. It doesn't cut through any of those boxes. Can we count to see how big side AB is? No, because now we're cutting across boxes. So to figure out the size of that side right there, we're going to have to use the distance formula. Do you guys remember our distance formula? Distance. It has been a while. Distance is equal to, and then we had a big square root sign, x2 minus x1 squared plus y2 minus y1 squared. And we have to use our points for our x1 and y1. What's the ordered pair up here for point A? Yep, the ordered pair for point A. 0, 3. What's the ordered pair for point B? For point B?
It's positive 4, negative 2.
Positive 4, negative 2, because we go to the right, yes. All right, we have to pick one of those to be our x1, y1, and one of those to be our x2, y2. Are you guys okay if we let A be the x1, y1? X1, y1, and we'll let point B be the x2, y2. So I would come over here to find the distance from point A to point B. We're going to do the square root of x2, which is 4, minus x1, which is 0. Close my parentheses and square it. Plus y2, which is negative 2, minus y1, which is 3. Close my parentheses and square it. And now we're going to simplify our parentheses. What is 4 minus 0? 4. So I have 4 squared plus, what's negative 2 minus 3? Negative 5. So I have 4 squared plus negative 5 squared. What is 4 squared? 16. And be careful here. What happens when you square a negative number? Becomes positive. What is negative 5 squared? 25. So I have 16 plus 25. What is 16 plus 25? 41. Is 40 square root of 41 equal to 8?
No.
What would that be in its decimal form? Grab a calculator for me and tell me what this would be in its decimal form, approximately.
I forgot how to put square root on my calculator.
You push second and the x squared key.
Alright, thank you.
You're welcome.
It's about 6.4.
Approximately 6.4. If we take it out to 3 decimal places, it's like 6.403. So could this be an equilateral triangle? Could this be an equilateral triangle?
Yes.
No, why not? Well, we don't know about the angles, but I do know that this side down here is 8 units, and this side over here is 6.4 units. So it could be scalene, or it could be isosceles, because we don't know about that third side yet. Yep. We don't know about this side yet. So let's find how big this side is. If it's different than 6.4 or 8, then we'll know it's a scalene triangle. If it's the same as 6.4 or 8, then we know that we'll have an isosceles triangle. But either way, it can't be equilateral. So let's keep A as our x1, y1. And then point C, what is that ordered pair for point C? What is the point for C? What is the ordered pair? -4, -2. Let's let that be our x2, y2. And again, we're going to keep this as our x1, y1. So to find the length from A to C, I need a big square root. I do x2, which is -4, minus x1, which is 0, close my parentheses and square it, plus y2, -2, minus y1, which is 3, close my parentheses and square it. What is -4 minus 0? So I have -4 squared plus, you guys already told me this, what is -2 minus 3?
-5.
So I have another -5 squared here. When I square a negative number, you already told me I get what type of number? A positive. What is -4 squared? 16. -5 squared? 25. Isn't that exactly the same two things that we added together underneath the radical before?
Yes.
Yes, so I'm going to get square root of 41, which you guys already told me is about 6.403. So this side over here is 6.403 units. So what kind of triangle are we looking at? Isosceles. This side right here is congruent to this side right here, which means what about angles C and B?
C and D,
They are congruent. They are opposite my two congruent sides. So they are congruent to each other. I don't know how big they are, so what could I call them? X and X. So I would have X degrees plus X degrees plus the 70-degree angle up at angle A equals 180 degrees. Combine my like terms together, my X and X, so I have 2x degrees plus 70 degrees equals 180 degrees. What do I get when I subtract 70 from both sides? 110. So 2x equals 110. And then I divide both sides by 2. What is 110 divided by 2? 55. So x degrees equals 55 degrees. What did we just find? Yes, the measurement of angle B is equal to 55 degrees. The measurement of angle C is also equal to 55 degrees. Very nicely done. Let's try another one that's very similar to this. Let's look at number 5. What are we supposed to find on number 5? All right, so angle XYZ, X up to Y, down to Z. So we're looking for this angle up here in the top corner, and angle YZX. That would be this angle down in the bottom corner. So basically angles Y and Z. is what we've been asked to find here. Do we know how big any of the angles inside this triangle are? We know how big angle X is. Angle X is a 90-degree angle. It's a right angle. So I know it's a right triangle. Do I know whether it is equilateral, isosceles, or scalene? No. So let's figure out how big the sides are. That'll let me determine whether it is isosceles, equilateral, or scalene. Are there any sides that I can just count? YZ. This is a perfectly vertical side, so I can count the squares. 1, 2, 3, 4, 5, 6. So this is 6 units. Can I count side XY? No. So we're going to have to do what we did before. I'm going to need some ordered pairs. What's the ordered pair for X? -3, +4. And what's the ordered pair for Y up here? 0, 7. Because remember, we don't go left or right at all, and that's always the first number, but we do go up 7. The Y, the second number, tells me how far up and down I go. All right, let's let 0, 7 be the X1, Y1. And let's let -3, 4 be the X2, Y2. So now to find the length from X to Y, we need a big old square root sign. I do X2, which is -3, minus X1, which is 0. Close my parentheses and square it. Plus Y2, which is 4, not -4, +4, minus Y1, which is 7. Close my parentheses and square it. What is -3 minus 0? -3. So I have -3 squared plus, what is 4 minus 7? -3. So I have -3 squared and -3 squared. What is -3 squared? +9. So I have the square root of 9 plus 9, or that would be the square root of 18. Is the square root of 18 6? No, so this is not the same size as side YZ. What is the square root of 18 in decimal form, approximately? 4.24. Right about 4.24. All right, so now let's find side XZ. This is 4.24 units. Side XZ, I already have X, that's -3, 4, so that's going to stay my X2, Y2. And now I need an ordered pair for Z. What is the ordered pair for Z? 0, 1. There's my X1, Y1 that I'm going to use this time. So the length from X to Z is equal to big long square root. We do X2, which is -3, minus X1, which is 0. Close my parentheses and square it. Plus Y2, which is 4, minus Y1, which is 1. Close my parentheses and square it. My first set of parentheses is exactly the same as my last set, -3 minus 0. So I have -3 squared. Plus, what's 4 minus 1? 3. So -3 squared plus +3 squared. Both of those come out to what? 9. So I have the square root of 9 plus 9 again, or the square root of 18, which is about 4.24. So this over here is approximately 4.24 units. So what kind of triangle is this? It's isosceles because xy and xz are congruent, which means which two angles are congruent? Angles y and z are the two congruent angles. Do we know how big either one of those is? No, so let's call them x. So I have x degrees plus plus that 90-degree angle over there at x equals 180 degrees. I'm going to combine my two like terms together. X plus x gives me 2x plus 90 equals 180. Then I'm going to subtract 90 from both sides. What is 180 minus 90? 90. So I have 2x equals 90 degrees. And then I divide both sides by 2. And that means x is about how big? X is 45 degrees. Which tells me the measurement of angle XYZ is 45 degrees. And the measurement of angle YZX is also 45 degrees. All right. So we had to use distance formula to find the length of the sides of the triangle so that we knew what type of triangle we were working with. You had it for me, dear. And then from there, we can determine that it was an isosceles triangle and use that to find the sizes of the angles. Let's look down at number 6, because number 6 feels a little bit easier to me. Because when I look at it, I know this has to be what kind of triangle?
Isosceles.
This has to be isosceles. How do we know? 12 feet and 12 feet. These two sides are congruent. So this is an isosceles triangle. Well, if that's an isosceles triangle, that means that two of the angles, the base angles, are congruent. What are the two base angles that are congruent here? What are the two angles that are opposite my two congruent sides? JK and JL are sides. I want angles. Yep. Angle L is opposite this side here, so that's one of my two congruent angles. And angle K is opposite the other congruent side. So angle K would have to be how big? Would have to be 60 degrees. And remember, these two angles, the ones that are opposite my two congruent sides, we call those the base angles. Now that I know that those are both 60, do I have enough information so that I can come up here and find the measurement of angle J? Yes. Measurement of angle L plus measurement of angle K plus measurement of angle J has to add up to how much? 180. It's only the angles that add up to 180, not the sides, just the angles. So I have 60 degrees for angle L. We have 60 degrees for angle K. We don't know how big angle J is. Add them all together and it equals 180. So let's combine our like terms of 60 and 60 together. What is 60 plus 60? 120 degrees plus the measure of angle J equals 180 degrees. Then I'm going to subtract 120 degrees from both sides. How big is angle J? 60 degrees. Measurement of angle J is 60 degrees. Well, now that I know that this is also 60 degrees, what does that mean about this triangle? This is actually an equilateral triangle. I thought it was isosceles. It met all the criteria of being isosceles, but it turns out that it's actually equilateral, but we didn't know that until we found the measurement of angle J. So how big is side LK then? That would be 12 feet. It would also be congruent.
So how we were able to determine LK?
Because it's an equilateral triangle.
Oh.
Yep, if it's equilateral, if all the angles are equal, then all the sides also have to be equal. All right. Let's look at the last one on this page, which is the last one we're going to do for today. Number 7. We need to find two different things here. We need to find the measurement of angle R, and we need to find the length of segment PR. What kind of triangle are we looking at? Yep, at the very least, this is isosceles. It might be equilateral, I'm not sure yet, but I know it has to be isosceles because we have our two congruent sides, 5 centimeters and 5 centimeters. So since I have two congruent sides, that means I have to have two congruent angles. What are the two angles here that are the congruent ones? P and R, opposite this side would be this angle right here. And opposite this side would be this angle down here. So those two angles have to be congruent to each other. I don't know how big either one is, so what could I call them? I can call them X. The measurement of angle P plus the measurement of angle R plus the 60-degree angle there at Q has to be equal to 180. And I'm going to actually write down angle Q right here. Measurement of angle Q equals 180, and then I'm going to make my substitutions. We're going to let angle P be X. Angle R is the same size, so it is also X. Angle Q is 60 degrees. Add them all together and we get 180. So I have X plus X, that gives me 2X plus 60 degrees equals 180. What happens when I subtract 60 from both sides? What is 180 minus 60? 120. And then I'm going to divide both sides by 2. And that means X is how big? How big is X? 60 degrees. And what were we letting X represent? P and R. So the measurement of angle P is 60 degrees. And the measurement of angle R is 60 degrees. Well, if those two angles are both 60 degrees, what kind of triangle is this? This is an equilateral triangle. All three angles are congruent. So it is an equilateral triangle. So how big is side PR then? 5 centimeters. This would also be a congruent side. So 5 centimeters. PR equals 5 centimeters. Beautiful. That concludes everything that we're going to do for today. And a little bit of good news. That concludes everything that I was hoping to get through tomorrow in our virtual meeting. You still have to come to the virtual meeting tomorrow because I will be taking attendance. That's how you get counted as being present for the day. for tomorrow? Schedule for tomorrow is up on the screen. So at 8:26, notice you only have 2-minute passing periods to go from one meeting to the next. Our meetings go from 8 a.m. to 11 a.m. You guys need to be in our meeting no later than 8:26. I will start by taking attendance. And then, since we got through all of the notes that we needed to get through, what we are going to do then is I will take questions, requests. It'll be a help session over the homework that is due on Wednesday. We've covered all the material that you need for that homework. If you need another copy of it, or if you were absent on Friday and you never got the first copy, down here, very bottom paper in this red organizer by the board is where you can find the homework that is due on Wednesday. So again, log into the meeting, take attendance. If you have questions about the homework, you need to stick around and ask those questions. If you don't have any questions about the homework, you are free to sign off and work on that homework, and then you can pop back in anytime between 8:26 and 8:50 if you have additional questions, if you run into a problem but you're already signed out. I will also hold office hours from 11 a.m. until 11:30 a.m., so you could pop in during that time also, all right? Now, there were some people that had difficulties signing into our practice session on Friday. On our main home page, I have posted the meeting ID and the passcode. So as long as you can get into Microsoft Teams, you could join with a code and do it that way. Hopefully this is working for everybody. People that were having problems, I went through and manually added them to our Teams course. So it should be showing up for everybody now, but in case there are any kind of technical problems and you can't get signed in, get into Teams, and then there's the meeting ID and the passcode there. Reminder, homework number 3 is due the next time I see you in person on Wednesday.